Okay, so I'd like to welcome to the stage Vince Varga from Castle Rock Microwave. Vince has more than 20 years in the communications industry, both building, designing, and selling the infrastructures, and he is here to give us our next speech.
Check. Yeah, thanks for having me. I was here last year. Check. Hello, Detroit. I was here last year. Not here, but PSCS last year. And I didn't have water with me that time, and you probably noticed about halfway through my presentation. So I'm prepared. Go ahead with the first slide. I'll make a quick introduction. Vince Varga, I've been doing wireless some things for probably over 2 decades, more than I like. But currently at Castle Rock Microwave, we're a secure wireless systems integrator. Design, build, maintain microwave systems, microwave backhaul, anything wireless, generally speaking. What we're going to go through today is presentation I call Protecting the Macro. When I say macro, I mean the two-way radio base station system. The elements that can impact that specifically are bidirectional amplifiers, BDAs, emergency responder in-building systems that potentially could inject noise into base stations and into the macro, degrading the performance of that macro. So if you remember last year, how many were here last year? Chunk, good, excellent. If you remember last year, we're going to get in, if anybody can tell me who the dog is. Anybody? Excellent. Who's the boy? Sherman. How are they related? Dog and his boy. Stepfather and stepson. So if anybody remembers this, I had some awesome. We okay? Check. If anybody remembers this, I presented 4 possible changes to policy and systems that could protect the macro. And they all had to do with BDA systems, or CES, Emergency Responder Communication Enhancement Systems, in-building systems to boost the two-way radio inside commercial buildings where you can't get radio coverage, right? As new commercial buildings come online, per fire code required to see if they have ample two-way radio coverage within those buildings. If they do not, you put in a BDA system to enhance that in-building radio coverage. So the 4 topics I talked about were communicate an ERCES, Emergency Responder Communication Enhancement System, BDA system, rules to the contractors that are responsible for designing and building these systems. Communicate BDA system submittal guidelines so that you have consistent results and you can validate the goodness of those BDA systems that are going into buildings so that they don't negatively impact your macro system. And track the BDAs that are connected to your macro system. As the BDA systems work, bidirectional amplifier inside the building, donor antenna on the roof, pointed to typically the closest radio tower, that bidirectionally that radio signal is amplified inside the building, and then first responders can have two-way radio coverage inside the building. Typically that's what a BDA system, how it operates. About a year ago we presented this, but there were no solution in place to do that, right? It was ideas I threw out there. Over the last probably 6 or 8 months, working with Douglas County Sheriff Office Radio Shop, with Douglas County School District as a owner representative, working with other AHJs, South Metro Fire in the area, and AHJ's radio shops across the country getting their best practices on what a good policy should look like. we came up with a draft of a policy that we're about to take to, Douglas County Sheriff Office Radio Shop is about to take to the county AHJs, authorities having jurisdiction, fire departments, to get their buy-in on this policy. So when we talk about what the motivation for this is, let's get a baseline of what the motivation is. So BDAs, same thing as BDA system, same thing as emergency responder communication enhancement system, ERCES, same thing as signal booster, same thing as in-building radio enhancement system. They're all called the same thing, different people call them different things, right? I'll call them BDA system just because it's short and easy to say, right? So these BDA systems enhance in-building radio coverage. A poorly designed or built BDA system can negatively impact the macro. Why? Right? Why is uplink noise caused by that in-building BDA, bidirectional amplifier, pushing noise into the macro, right? Thereby desensitizing the receiver. So what? You desensitize the receiver, your far out coverage, then it gets weaker, right? The portables, the mobiles on the far edges, right, can't get back with enough signal to noise ratio, so that the outside of coverage of your area is going to be lessened. That circle of coverage is going to be shrinking down. That's the motivation. And general degradation of your macro radio system is the negative. AHJs, keep in mind AHJs, authorities having jurisdiction, fire departments, enforce International Fire Code. The section on BDAs is section 510 if interested. And there's National Fire Protection 1225 as well, has some elements talking about the good design, construction, and maintenance of these BDA systems. The IFC, International Fire Code, I can't see that, by the way, so I'm going to go over here to, if that's okay. International Fire Code references FCC 47, Part 90, use of signal boosters. And in that claim of the IFC, International Fire Code, pointing to FCC, the license holders, SU, are responsible for consent of using that license within your geographic area. Part of your geographic area is inside the building. You have the authority as a license holder to enforce the use or not use, the retransmission or not retransmission of your license spectrum. That is, you've got the power to say yes and no. So you want to say yes when it's a good BDA system, because that BDA system is actually helping the public safety by allowing two-way radio inside the building. And you want to say no, or maybe, and probably no, if that BDA system is causing you noise, bad and degradation of your macro system. You do not want to give up the health of your macro system, right? Does that consent, right? So I'm sorry, in FCC, must maintain, license holder, must maintain a reasonable level of control over the operation in order to stop interference problems, right? So does that consent, I'm going to ask the field, ask you guys and gals, does that consent happen? Does that radio retransmission happen? Yes or no? Show of hands, no. Show of hands, yes. Show of hands, sometimes. It's mostly sometimes. What we want to do with this policy is make sure that that happens a lot more and every time, so that you, as radio license holder, have that control and know where these BDA systems are and know what they're doing and know that they're not having a bad influence on the macro. So the idea here is a mutually agreed to policy that can bridge the AHJ fire department, because they have consent over the safety of the in-building fire systems, of which BDA systems is one. So we want to bridge between the AHJ and the radio shop, basically, that has that license. With a common goal, right? Those common goals are protect the public good, right? Make sure you have good two-way radio system inside the building in case there's an emergency. You want to be able to talk out. Protect the macro protect the macro network, as well as enforce fire code as required by IFC and NFPA. So where the water comes in. So the goals of the policy were, number one, well, actually this isn't in any order, right? Multiple parallel goals. Protect the macro network, protect the outdoor radio network. Do not impose on AHJ's realm. AHJ, fire department, are responsible for enforcing fire code. This policy doesn't say anything about fire code other than there is an AHJ and they need to enforce fire code. This policy is purely to protect the radio network and not step on the toes of the AHJ, right? Give good direction and meaningful information to systems integrators. These are the third parties that do the design, the build, the maintenance, the testing, the annual and 5-year testing as required by International Fire Code of these in-building radio systems. So we want to give them good direction so that they do good design, they do good testing, and the resulting system doesn't negatively impact the macro network. We also wanted to set commercially reasonable requirements. We could have built a policy that said the BDA system has to be bulletproof and 7 times redundant and would have cost $14 a square foot. No commercial real estate person, you would have got pushback and punches in the face, right? Saying, I can't build my building and have this public safety system in place at a reasonable cost. Right? We wanted to get away from that, make it a reasonably priced system for the level of risk we're taking and the amount of safety it's providing, right? We're also looking for AHJ approval, and that is in progress today. So this is in cooperation, actually driven by, I'm going to, instead of saying cooperation, I'll say driven by Douglas County Sheriff Office Radio Shop. We had Douglas County School District as representing like the end user, if you will, like an owner, commercial building owner, as input. We had South Metro Fire. Mike Brownson, if you know the name, wrote a book, literally wrote a book on BDA system best practices. We had his input. We had input from OEM, PCTEL, input from Castle Rock Fire, and input from a number, like I said, a number of different agencies around the United States that had similar policies that we basically absorbed into this policy, chose the best of those. All right. So the first part of the policy talks about pre-BDA testing. This occurs when a new commercial building is about to open, it's a year from opening. Substantial construction has been completed of that commercial building, hotel, school, whatever it might be, right? This isn't residential, this is commercial buildings. And a test has to be performed inside of that building to see if it has ample two-way radio coverage per International Fire Code, right? Do a grid test, create a grid across each floor, test each grid for a given signal level. If it's above a given signal level, it passes. If it's below that signal level, it fails. And then based on the amount of percentage of passing grids, that building passes or fails. If that building fails, put in a BDA system. If that building passes, no BDA system required. Right? So the question is, how do you get consistent results out of that testing? What I've seen over the years, just in various roles, is that the systems integrator tested on the wrong control channel, or tested on a talk channel, not a control channel. So think about if you're doing a signal level test and walking through a building, you're not testing on a control channel, but actually a talk channel. I'm going to say, good, hey, someone's talking, hey, it's good and hot. Oh, it failed because they're not talking anymore, right? It's got to be consistent tone to test against, right? So that's got to be control channel. That's one example of the kind of guidelines that are in this policy. So the policy defines test parameters. Those test parameters are sent to the property owner. Typically, it's going to be the systems integrator that's representing the property owner, right? What we're looking for is in addition to the fire code mandated minus 95 dBm for a signal level pass-fail, above and below, we're also looking for 20 dB of signal interference noise ratio. You can operate a two-way radio in building perfectly fine at probably minus 100, minus 102, maybe a minus 105 dBm. as long as your SNR is above a given level, right? Fair enough? So we're looking for a 20 dB SINR, 2% frame bit error rate, and maintain that minus 95 dBm. That's per fire code. There could be situations where the building passes, corner cases, I'll give you that, where the building passes because you're over minus 95 dBm throughout the whole building, throughout the whole facility. But your SINR is 10, is 5, is 14 dBm, right? In fire code, it says test DAQ, delivered audio quality. That's a subjective measurement of, can you hear me now? Yeah, can you hear me now? Hey, Jake, the quick brown fox jumped over the whatever, right? So it's an analog, if you will, human-interpreted level of quality. SINR, there's a direct correlation between SINR and DAQ level, proven. A SINR of 20 dBm gives you a DAQ of about 3.4, which is basically very clear. You might have to repeat once, something along those lines, right? So we think it's a reasonable requirement that gives good quality audio within the building. The bit error rate is purely how many packets did I lose in transmit and receive, and the minus 95 is per fire code. Part of this, since we're putting these requirements on the systems integrators, now keep in mind when I say we, I've been working with Jeff Vaughn and Stephen at Douglas County Sheriff Office Radio Shop for 6 months or so on this. So when I say we, it's the team of building this policy. So because the policy requires testing to these levels, we want to ensure that testing is done consistently and with consistent results. To do that, we're dictating the use of a specific OEM's test gear. Company's called PCTEL. They've been around forever. Because that system integrator may not have PCTEL gear as part in their repertoire of tools, Douglas County is going to be loaning out, as needed, loaner gear to those systems integrators such that they can perform those consistent tests. Right? Once those test parameters are understood by the systems integrator, the owner or the systems integrator performs that grid testing. Pass-fail results are determined. The pass-fail results are uploaded to a central database that's accessible by the sheriff, in this case, Douglas County Sheriff Office Radio Shop, as well as any AHJ, whose jurisdiction that is, as well as the systems integrator who did the work. So now we have a central database of those test results for posterity and to go back and to say, yes, tests were done, and yes, they passed, or no, they failed. Both Douglas County Radio Shop and the AHJ review those results and determine, yeah, we agree that the building failed or the building passed, right? That i.e. a BDA system is or is not needed. And then the AHJ, actually the AHJ, the fire department, determines if that BDA system is needed. The radio shop just says, yeah, those are consistent results. Yes, I agree with those results of pass-fail, right? But the decision, the mandate to put in a BDA system is upon the AHJ, the fire department, not the radio shop. Make sense so far? Just anybody can say yes or no. Thank you. So that's determining if a BDA system is needed or not. Right? Now let's go into what the design parameters and a consistent submittal might look like. Right? So the policy gives radio, tower, oh, too close, radio transmit power, output, the channels, the control channels, and the number of channels, talk channels, the donor site locations. That gets to the systems integrator such that that systems integrator can run a downlink link budget and an uplink link budget, right? Why do we do link budgets? You need to prove to somebody that this BDA system will do what it says to do, right? With not enough, with no noise injected back into the macro, and with ample signal down to get inside the building. Right? The SI is systems integrator. The systems integrator submits links budgets. That's both for downlink, uplink, what we call near field, uplink far field, and uplink noise. Based on those link budgets then, and let's go through uplink, near field, and far field. If I say near and far field, does that make sense to anybody, or should I explain it? Explain it? Explain it. Let's say there's a BDA system in this conference center, and there's a service antenna, an in-building antenna, right above me, okay? And I'm a firefighter, and there's another firefighter, and that's the only antenna in this room. There's another firefighter that's 84 feet that way, right? The signal coming from my portable up to that donor antenna through coax to get to that BDA amplifier is going to be relatively hot, relatively high signal level. A different firefighter 84 feet away is probably going to be 10 dB, I'm making it up a little bit, 10 dB less, right? This one antenna has to serve both the close person and the far away person. If this close person talks to, if the BDA compensates for this too much power getting into it and lessens its gain at the BDA, I just starved the firefighter on the far side, right? So I need to ensure that both the far away emergency personnel person and the nearby to this antenna both get served equally, and I don't starve one over the other. I don't overpower the BDA by being too close. So those link budgets, they're purely calculations, right, of power losses, gains, power loss gains from a two-way radio through a BDA system, through a rooftop antenna, over the air to the tower, right, and the reverse direction. That's downlink, and that would be uplink, right? So we want to see those link budgets and that they're valid, right? One, so the BDA system is useful and correct, and so that you're not overpowering something or killing the macro in other ways. So we'll take a look at that. The policy also dictates Class A BDA only. There's two classes of BDA, class per FCC, Class A and Class B. Class A is a channelized, that i.e. it amplifies only certain radio channels, 12 kilohertz channels, right? But only certain ones. A Class B BDA is a wideband BDA, maybe 75 kilohertz wide, that passes everything that comes into that bandpass filter, right? Everything. And it doesn't select radio channel, it doesn't select public safety radio versus baby monitor that might be close, but off, right? So this is dictating for a higher quality system. They're slightly higher in price, but we think it's reasonable for the market that a Class A BDA will be required, not Class B. Single BDA per building or campus. If you can't cover the in-building radio coverage by a BDA, a single BDA, you're not going to put a second BDA. Causing a second BDA loops, more noise injected back to the macro. There are systems out there that are fiber fed, i.e. a single core BDA unit, fiber out to remote units, and those remote units are powered and then fill the rest of the space. You'd see something like maybe an Amazon warehouse, something that's probably over maybe 250,000 square feet, roughly, where you need a fiber-based system. We don't want to have these multiple BDAs all interfering with each other, trying to get back to the same thing, servicing effectively the same building. So use fiber-fed or a fiber-based system where needed. On the downlink, we want to minimize BDA gain, because by minimizing BDA gain, you're also minimizing noise injected into the system. That also minimizes bleed out of the inside signal getting outside the building. We're saying minus 95 dBm at the edges of the building, at the edges of the inside of the building, right? If possible. And the delta between any two service antennas inside the building, no more than 6 dB delta between the downlink of this antenna and the downlink of this antenna. What does that enforce? That enforces a denser antenna placement so that you're not serving a building of this size with one service antenna inside. Why is that? Because now I have a near-far problem. I've only got one antenna serving this whole area. I got somebody that's really close, and I got somebody that's really far. Generally, bad things happen. So it forces a higher antenna density, in-building higher antenna density. That's for the downlink. For the uplink is inside the building, getting back to the tower. On the uplink, again, minimize the BDA gain as much as possible. Minimize the transmit power, and minimize the noise. We say a delta of no more than 30 dB, a delta of no more than 50 dB power distribution. Again, that goes to the in-building service antenna density. Right? The reason is because if you get close to the dynamic range of that bidirectional amplifier, you either clip it, someone's too close, and you end up clipping that too close power, and it drains power for everybody else, right? Or it can't gain the far away user enough. So we put parameters on like a high-low of how different those signal levels can be getting to the BDA, minimizing the near-far effect. Right? We're limiting donor antenna. The donor antenna is the antenna on the roof that feeds the BDA inside the building, and that antenna, donor antenna, points to your radio tower. That's where it's getting signal from and to, right? We want to narrow that beam width. We don't want to omnidirectional, for sure. 90 degrees is even too wide because there could be another building adjacent, and now you get some weird feedback loops on the system. So it's about, I want to say it's about a 40 degree, maybe 40 degree vertical, 40 degree horizontal is the limit. We get any tighter than that, the antennas get really big, right? This is 700 and 800 megahertz. The gains get higher, so you're dropping gain, the antenna gains get higher, you're dropping gains on the BDA. It gets very expensive, right? And the size of those antennas get very big, right? So it feels like a commercially reasonable and RF reasonable limitation on donor antenna beam width. In addition, we have something in there for emergency RF power off. So we didn't want to disable the BDA completely. In the case, here's why. In the case there's a problem with the BDA, let's say there's an oscillation problem. An inside signal gets to the donor antenna, comes back down, gets amplified, gets to the out antenna, and then you get this, but on an RF level, right? You want to get rid of that. So we have an emergency power off method such that the radio shop can get into the BDA either mechanically or remotely, virtually over some network to be able to disable RF at any time in case there's a problem, because that negative problem with that BDA potentially could cause a problem with an adjacent BDA, or if it's shooting in the back of another BDA, or worst case is messes up your macro, which could affect other things. So we want to, in this case, protect the macro and have the ability as the license holder to disable that radio transmission at any time. So far, so good? Thank you. How are we doing on time, by the way? Bueno? Excellent, thank you. All right, so BDA acceptance testing. So this part of the policy is once the BDA system is in place, it's in the building, BDA's in place, battery backup's in place, coaxial cables, splitters, couplers, service antennas, more splitters, couplers, service antennas, maybe fiber going to remote. Once that's all in place, it needs to be acceptance tested by the fire department and by the radio shop to say, yes, you can bring that online. Because if you don't say, yes, you can bring it online, and the systems integrator or building owner turns it on and it causes havoc on your system, who turned that on? Why are they turning it on? Why do I have these problems that now you're hunting? You're stopping what you're doing because your macro is degraded, right? And now you're hunting for something that you didn't even know about. So there's a method of acceptance testing where you approve, as radio license holder, you approve. And that acceptance testing is actually a set of steps to actually do testing, not just observing, right? So for downlink, you're going to look at donor signal level, and you're going to look at SINAR, signal interference noise level. You're going to look at the donor and service antennas isolation to prevent oscillation, that feedback loop, right, of indoor antenna to outdoor antenna through amplifier. You want to negate that, right? So there's testing performed in order to ensure that that will not happen. You want to look at surface antenna signal verification on the downlink. What's my signal level? Again, kind of like a grid walk you did before the BDA was put in place. Now you do a grid walk after the BDA is in place. The signal level should be substantially better, substantially higher quality, right? That's why you put the BDA system in. And then you also want to look for external RF leakage from inside that BDA system leaking out of the building into the area around it, right? You want to minimize that because as a emergency, a firefighter, police, sheriff, what have you, walks up to the building, you want a dominant signal for the portable to talk back to the macro, either directly to the macro through the air because you're outside the building, or once you're inside the building by way of the BDA system and then out. As well, we'll do some tests on the uplink. We'll look for noise and channel power. Now this actually requires a special piece of equipment in order to do, but there is equipment out there. Douglas County Sheriff Radio has some equipment from PCTEL as well that looks at the base station, a tap port effectively on the base station that could observe the uplink, both in signal level and signal quality, et cetera. So at least in Douglas County, as that's in place, this uplink signal testing will be important to check at noise level before BDA is put on, noise level after BDAs come on, and that better not move an inch, right? That should be either, you should see no effect in a well-designed, well-deployed BDA system. You should see no effect of that BDA coming online. Now, a lot of BDAs coming online, it's a new commercial district, right? And you've got 12 or 15 buildings, and they all require BDA systems, right? That effect, that aggregate effect, right? You may see an increase in noise, but that's what you want to know about. And that's, if you can't manage what you don't monitor, right? This is monitoring these in-building BDA systems. All right, get some water. I spoke a little bit about a central repository or a central database for information about these BDA systems. There is software out there. This has been adopted by Douglas County Sheriff Office Radio Shop as well. It's cloud-based. It's effectively a database with some maps. There's a workflow built into it such that as a systems integrator submits a design package for a new BDA, that can be assigned like a next step in a workflow for someone else to review it, a notification to be sent out. It's a repository for the test results. It's a repository for all the design submittals and test submittals, and it gives a nice map of here's my macro tower or towers in my system. Where are all the BDAs that have been installed from this date forward? Right? So now you know where those BDA systems are on what commercial buildings, et cetera. So it's also a location where you can upload these grid tests. The AHJs could log their approval or disapproval on the system as well. The acceptance testing results, the detail of those acceptance testing results can be uploaded to this location as well. Right? As well as any retransmission approval letters. You as the radio shop, this is why we're doing this. You own the license. You license that spectrum. I was going to say own, you don't own it. You license that spectrum. You have the authority to approve or disapprove. You probably do that on an annual basis or maybe every 4 years or 5 years to reapprove that. You want a record of that. That record is probably in a vertical file somewhere on a piece of paper, right? Let's digitize it. Let's get that approval signed by parties and into a central location where the AHJs have access, where you as radio shop have access, where systems integrator who did the work or is going to do the work has access, right? We think this brings all the important parties to make a good quality system into one place for better communication. That's the hope. That's the dream. And any annual retesting of that BDA system as required by fire code, those test results could be uploaded here as well. Typically, you'll see those kind of records in a red firebox next to the BDA on a piece of paper, right? But who has access to that? You know, the building owner, AHJ if they remember, a radio shop if they remember, right? But now with the central repository, it's a nice central location. It's accessible to the people you want access to. What is this? I can't read that. Oh, here's some unique elements. So the policy intends to enforce good design, good construction, right? Good operation, right? Of these BDA system that could cause negative effect on your macro network. Okay. Some unique things that are in the policy. We just talked about the central database. That's kind of a new concept, really. Right? It does require that those systems integrators, the person that are performing the design and the build and the testing, be certified. That's either through NICET, which is a fire protection that has current certifications for BDA systems now. ETA, the OEM, the BDA manufacturer, typically has their own certifications, as well as IB-Wave. IB-Wave is a computer-based tool for actually predicting designs, creating heat maps, layout of the floor plan, place my antennas here, what does the heat map, coverage heat map look like? That certification is required as well as FCC is a GROL, is a General Radio, help me out, General Radio Telephony Operator's License. Thank you, it's a mouthful. Yeah, so those are going to be the requirements for certification. We didn't want to put the certifications on day one because one, this hasn't been adopted by the AHJs yet, right? But as soon as it is, we want to give some time to the systems integrators. This may be new for them. If they're a decent systems integrator, they should know about NICET and the other certifications. But for whatever reason, if they don't, we want to give them some time in order to get that certification versus like totally blocking them out of commercial opportunities. FCC requires that you register on an FCC database only Class B BDAs. This is requesting that you register the Class A BDAs. Although not required by the FCC, I made a call to the FCC and they said, yeah, it's perfectly fine to register a Class A BDA. So in a central, yet another central database, right, the FCC should be the official, right, you now can see all BDAs in your geography. It's starting as soon as the first person starts registering. Not all even Class Bs are registered, man. I've seen a lot of these systems and some of them aren't even registered on FCC. So that's an enforcement problem, but it's not for me to solve. And then the annual letter of authorization for retransmit. A lot of times it's a one-time, a one and done, but we want to enforce an annual retransmission authorization. So that authorization happens every year. So at least you know if the building changes, if the ownership changes, if there's any changes to the facility at all, that would be caught by, you only get permission for 1 year to retransmit. We're going to check it every year. That's it. I think I'm pretty good on time. Two other things. If there's more time at the tail end, I'll do Q&A if you need it. Or our tabletops back here. It's Castle Rock Microwave if you want to stop by and talk for a little bit more. We're doing a AHJ event. This is an educational event for fire, but there's no reason why you guys can't attend as well. So the idea is to talk about this policy in more detail, talk about these BDA systems, good design practice, good build practices, the so whats of them, et cetera. If you want to scan that QR code or stop by, that's happening on June 26th at South Metro Fire is donating their space for half a day for that. If you want to talk to me, that's my QR code, but I've got business cards if you want to do paper as well. Make sense? Yes. All right. Questions? Do I have a couple minutes for questions or no? 5 minutes for questions. If not, perfectly fine. If so, that's great. Don't be shy. Yes, sir. Got it. So the question was, I mentioned an emergency power off for just the RF part, right? We recommend two methods and have options for two methods. One is like an EPO on the outside of the building, right, near the Knox box, that's keyed for radio shop. Hit it. It's a two-wire, right? Two-wire. It doesn't disable the power to the BDA because then you're powering out the whole BDA, and now you got to start the BDA back up. You got to power on self-test, and you're 4 minutes away. So it just shuts off it opens the RF path, right? That's one method. So a manual, open it and turn it off. The other is a newer technology from I think the company's called Response Link, LINQ. And they've got a way by way of cellular or terrestrial backhaul of getting into a BDA to disable. So that's like a remote connection, if you will. So those are two. We're not sure which one is going to be adopted over the other quite yet. Does that make sense? Yeah. Yeah, it is, we kind of had to standardize on one. So it is the PCTEL. The good news is for HJ and Radio Shop, at least for HJ and Radio Shop, those licenses are at no charge from PCTEL. So there's no cost to the agencies, if you will, right? So a lot of the systems integrators already are using PCTEL scanner, other PCTEL equipment. And I think with that, don't quote me, I'm not a PCTEL rep at all, right? So don't quote me. But with that, I think there is some access or lower cost access, or included in your annual maintenance of that is access to the central platform. Go. All good? Just one person needs to say yes. Thank you.
Okay, so following on the heels of the BDA information that was just presented, for HJs and licensees only, so no installing companies, please. But Chris Cull from Combo USA is actually in the breakout room, which is out through the doors just past the registration table and to the left. If you are interested in going out there and taking the class that he has going on for the rest of the day on in-building solutions and best practices,